The following presentation covers enhanced design placement and reuse capabilities for Cadence OrCAD and Allegro PCB Editor customers using EMA CircuitSpace. As PCB designs become more complex and project timelines more compressed, it is important to identify opportunities to enhance the design process. Component placement and design IP reuse is one of those areas that can be made much more productive and much less time-consuming by applying design automation to the task. Typically, this area has been low on automation due to overall complexity and variability that is inherent in each unique PCB design generated. However, if this process could be sped up and design effort reduced, there would be a significant benefit, as design placement can consume large parts of the design schedule and have a significant impact on overall design closure times. With an automated component placement process, users can dramatically increase productivity while significantly reducing time to market and time to profitability. There have been attempts to address this area of design with automation tools. Typically, these solutions are rigid and inflexible, meaning they require design characteristics to be static between designs or between sections of the board to operate properly. They do not allow for sometimes even small changes between circuits, resulting in the designer being limited to the restrictions of the tool, not their ability to innovate. As a result, these methods have focused on large functional blocks for reuse, as the benefit of reusing a large block can then outweigh the limitations of being forced to reuse that block exactly as is between designs or between sections of your design. These solutions work, and there's value to be had, but anytime you hinder a designer's ability to innovate based on the tool limitations, there is design efficiency and performance left on the table that is not captured. What is needed to enable users to fully leverage their design IP and accelerate placement is a flexible solution that allows the designer to reuse their IP without being limited to the exact conditions that IP was originally created in. This type of methodology enables designers to repurpose their IP from design to design without forcing them to limit the new design to the requirements of the old one. With a tool like this, design reuse can be leveraged at any level, from large functional blocks to a single BGA and all its support circuitry placed around it. This type of reuse frees the designer to focus on the differentiating aspects of the product, as opposed to the tedium of repetitive tasks like placing bypass caps in the pin field of your BGA device every time you use that BGA in the design. EMA CircuitSpace is the flexible design placement and reuse tool that allows you to fully leverage your previous design work. Its bottom-up approach enables it to handle design differences between the current placement IP and the design you want to reuse that placement on. This flexibility is what differentiates CircuitSpace from other methodologies available. As stated before, enabling a flexible design reuse methodology provides all the benefits that can be gained by IP reuse, while eliminating the drawbacks inherent in other processes. Users can take advantage of their design IP knowing they will still have the same flexibility to design to the unique requirements of their current project. CircuitSpace is seamlessly integrated into the Cadence OrCAD and Allegro flow, operating directly within the PCB editor menu structure. This enables CircuitSpace to be a drop-in addition to your current design process without the need to learn a new UI or design tool. Customers using CircuitSpace have seen design cycle timelines reduced by weeks, sometimes up to 50% design cycle time reduction using this methodology. Now that we have outlined the benefits of the CircuitSpace design methodology, we will now begin our demonstration showing you how CircuitSpace opens a new paradigm in PCB design placement and reuse. One of the immediate benefits customers can utilize with CircuitSpace is its ability to help group components and provide initial placement of component groups. This helps give designers a head start as they begin to place their parts on the Allegro canvas. Instead of placing one device at a time, designers can place functional blocks of circuitry, effectively raising their level of design abstraction for placement. As you can see, we are currently inside the Allegro PCB Editor GUI. CircuitSpace operates directly within the Allegro PCB menu structure, so anytime you use CircuitSpace, you are automatically and natively updating the Allegro database as well. For this example, we'll show you how you can auto-cluster your components into groups. CircuitSpace allows you to do this automatically based on connectivity defined in the schematic. For this design, we will auto-cluster all the parts, so you can see how quick and effective this is. As you can see, CircuitSpace has clustered the parts into groups based on connectivity. In this case, it has clustered each IC in the design and its related support circuitry. These clusters can now be moved and placed as a group on the board. By clustering the components by connectivity, you are increasing your chances of design routability, since all components and their immediate support circuitry will be placed together. Now that you have created the clusters, CircuitSpace will take placement even further by helping to auto-place the support circuitry around the IC. Using the autoplace command, you will see that CircuitSpace has positioned all the discrete parts around the IC. This command uses the CircuitSpace algorithms, which take into account connectivity, as well as voltage requirements and fan-out requirements to provide a valid placement. Of course, the designer is free to massage and tweak the placement to their liking at all stages of this process. But with CircuitSpace, the user has gone from a buffer full of parts to an almost totally placed BGA in a matter of minutes. Once you have defined the desired placement for your circuit, you can then replicate that placement to other like circuits in your design. As we stated before, the other circuits need not be 100% similar to the reference circuit for CircuitSpace to identify them and apply as much of the defined placement as possible. As you see below, CircuitSpace has replicated the original placement to the other similar components in the design in a matter of seconds. And since CircuitSpace knows all these clusters were developed from the same initial placement, any changes to one can automatically be propagated to the others, avoiding eco-based errors in your design. These are just some of the capabilities CircuitSpace provides to help you develop a rapid and accurate component placement within a single design. But what happens when you want to reuse circuitry from a previous design? This is where the flexibility and power of CircuitSpace really shines. In this example, we will develop a template for an IC and its associated circuitry in one design, and then reuse that template in another, even though there are significant differences between the designs. One of the powerful capabilities is CircuitSpace can cross-probe between the PCB and a PDF of the schematic to help with cluster selection. We will select the components in the schematic, which will in turn be selected in Allegro PCB. Once we have the desired component selected, we can now save that placement off as a template. Included in the template can be any etch and shapes that are within the template boundary. Now that we have saved the template, we can go and use this template in another design, taking the placement and routing used in previous design and applying it to the current one. We will now apply that placement to the new design. Since we have already clustered the design, we can just select the similar BGAs that we want to use the previous placement on. As you see, CircuitSpace has replicated the placement from the other design to the similar BGAs selected. Notice the placement defined in the new design differs from the template. The number of components are different, as will happen between designs, yet CircuitSpace was still able to identify all the relevant matching parts and place them appropriately. This flexibility to adapt your IP to the new design is a unique capability within CircuitSpace. The designer is able to reuse a previous placement IP without forcing the new design to exactly match the old one. You may remember that in the previous design, the etch was already complete for the circuit we used as a template. In this case, the layer stackup is different between the template design and the current one. Being a flexible reuse methodology, CircuitSpace allows you to map the old stackup to the new one, so you can maintain the etch from one design to the next. Being able to map stackup between designs is another example of flexibility in the reuse methodology, especially as one of the key cost factors in PCB design is layer count. With CircuitSpace, you can confidently reduce and or change layer count between designs without sacrificing your design IP reuse options. This was just a brief example of the capabilities and flexible automation CircuitSpace provides to the Allegro PCB design flow. As you have seen, CircuitSpace differentiates from current design reuse methodologies by providing a flexible environment which allows users to maximize the amount of IP they can repurpose from design to design without inhibiting their abilities to meet the unique requirements of each design. This tool, coupled with the powerful design and editing features of the Cadence OrCAD and Allegro PCB editor, allows designers to move forward with confidence, knowing that they will always be able to complete even the toughest of boards within their project schedule. Thank you for joining us. For more information, contact EMA Design Automation at 1-800-813-7287, or you can visit us online at www.ema-eda.com. EMA is a Cadence channel partner serving all of North America.